A very good afternoon, everyone. I'm Rukshan Senanayaka, and I worked as a software engineering intern at WSO2 recently. And currently, I'm a final year IT undergraduate at Faculty of Information Technology, University of Moratuwa. And I'm an AI ML enthusiast and, of course, a cloud enthusiast. And I blog, and recently I started creating my own content to share my knowledge with the world. So that's a bit about myself. And now in this talk, we're going to talk about how we can extend the Kubernetes with operators. Now, this is the overview of my presentation. So first off, we are going to have an introduction of what Kubernetes operators are, and then we'll see what problem do they solve, and then we'll learn some concepts like custom resource definitions, where to find the Kubernetes operators and the operator lifecycle manager, and of course, a hands-on approach on how you can create your own operator as well. So, at the end of my talk, I want you to take only 3 key takeaways. That's it. Okay, nothing more. Just what's an operator, what problem it solves, and then how you can get started. So just 3. If you can take these 3, then you're good to go. Okay, then what's a Kubernetes operator? If you have heard or seen, vintage movies, then you have seen, these telephone operators, right? So they are like specializing in routing the telephone calls to wherever it needs to go. So that's an operator, but that's the telephone operator, of course. But that same analogy can be made into Kubernetes as well. And that's where Kubernetes operators come. So our lo and behold, ChatGPT-4 says a Kubernetes operator is a software extension, but look at the bold words, that automates, and of course, custom resources and controllers, and another bold phrase is specific application or service. So these are the things that you have to pay attention to when you're talking about operators. They are all about application-specific domain knowledge and automating those things. So manually, we don't have to worry about applications and all the complexities associated with them. We can hand over all those domain-specific knowledge and embed it as logic within our Kubernetes operator. That's all there is to the Kubernetes operators. Okay, I hope that's clear. Then why do we need it? I mean, Kubernetes is as complicated as it can be. Then why do we need to complicate it with another thing called Kubernetes operators? Now the thing is, Kubernetes is a solution which is great for enterprise corporations. But the thing is, they may have various complicated applications that require specific domain knowledge to deploy them, manage, update, and of course to maintain them as well. Now hiring those professionals with those specific knowledge, domain knowledge is good, but they can be costly. So why not, if we could, offload that domain knowledge into an operator which can automate all these tasks for you? That's of course what's done by a Kubernetes operator. So day 2 tasks like upgrades, backups, and restores, scaling, these things can be offloaded as logic within your Kubernetes operator. Of course, since we are using Kubernetes operators, we can abstract away the complexities so the developer or the user, mainly the user who uses your application software on Kubernetes, can use just a simple YAML file to deploy the application, and of course, the rest is taken care by the operator. Now, there are several capability levels in an operator. So in the previous talk, I think you were made familiar about the Helm. So you can see Helm covers 2 capability levels. That's the install, the basic install, and the upgrades. So when you have an application to be deployed in a Kubernetes cluster, you can use Helm to deploy it and then make the upgrades. But what about all the other things like controlling or managing the full life cycle, getting monitoring, deep insights, and of course, the horizontal and vertical scaling according to your business requirement needs. Now, these things cannot be done simply just by using Helm. That's why we are using Kubernetes operators. Now, operators can be created in various ways, like you can use Ansible or Golang. So I did my internship at WSO2, and my project was related to Kubernetes operators, and I developed it using Golang. So I'm familiar with Go, and I'll explain the code in Go as well. So the most important thing is custom resource definition. What is the custom resource definition? I hope in the previous talk, one of the previous talk, you saw some operator being used for the virtual machines. Like that, whenever you have a specific business application and you want to have a Kubernetes operator for that, you would create custom resource definitions. For example, you have native Kubernetes resources for deployment, stateful set, config maps, secrets, all those stuff. They're good. But what if you have your own application? For example, MongoDB. We are all familiar with MongoDB, the database. So MongoDB has their own operator for Kubernetes, and they have their special custom resource definition called MongoDB community. And what you can do using this custom resource definition is you can have a YAML file, and in that YAML file, you would be putting the kind. If you're familiar with YAML, it's just a kind, and that kind will not be deployment, it will not be stateful set, but it will be MongoDB community. It's custom, right? It's specific to MongoDB. Like that way, you can have your own applications in Kubernetes and create your own custom resource definitions. That's the beauty of using operators. Now, this is just a basic big picture idea of how it all comes together. Now, we know Kubernetes has an API server, right? So they have the resources, and we create objects to deploy our applications. That's good. But what if we want to extend those API server capabilities? That's where we create API groups, but for our own application. So here you can see they have created something called a tunnel. Okay, so that is specific to their business requirement. Like that way, using these custom resource definitions and controllers, we can extend the Kubernetes API. So there may be pods, deployments, stateful sets, but with these, you will have, maybe I can create another custom resource with my name. I can create, kubectl apply, and then I do some custom YAML file, and then kubectl get Rukshan. So that will be the custom resource definition that I create. Okay. Where do you find these operators that were created by other people, the community? You can simply go to operatorhub.io, and there's a collection, huge collection of operators that are already created. And when you want to install an operator into a cluster, you'd have to use the OLM, or the Operator Lifecycle Manager. So I'm just giving a brief introduction on these things, so I'm not going to go into any much detail into these things. Now, if you are familiar with Kubernetes and operators or controllers, or if you have heard of them, you might have heard the word controllers also. So what's the difference between a controller and a Kubernetes operator? Let me put it like this. Simply, an operator is a domain-specific controller. Controllers are there in Kubernetes as well. For example, if you get a replica set or a deployment, then you can have specific controllers for them. And that controls how the resources are created. Then what's the big deal with operators? Now, in an operator, you can have several controllers, and you can have your own business logic in them. That's it. So controller can be a single thing. For example, for a replica set, there is a controller. But for an operator, there can be multiple controllers. So it will be evident in the code we have in the demo. So how do we create an operator? There are various tools like Kube Builder, Operator SDK, but I have familiarity with Operator SDK, which is built on top of Kube Builder. So it will be very easy for you to start an operator project. So I'll show in the demo as well. Okay, now the demo. I hope I won't look like this at the end of the demo, because I tried it, I tested it, and now let's see it in action as well. Okay, let's create a custom operator. Now, creating a custom operator is, I'm not going to say very easy, but with operator SDK, it's going to be easy. So here, I have already coded, so I'm not going to code everything from scratch. But here, so this is how you can initiate an operator SDK project. So for this, you have to have operator SDK CLI, the command line interface, installed on your computer. So I have. So you can see it's just an init command, like git init. You say operator SDK init, and you pass all the arguments like the name of the operator and what's the domain of your operator and any GitHub repo, like those things. You can just put and hit enter. And then you can see all the project files and the folders are scaffolded. So everything you need to get started with an operator is there. So if you look at the project structure, it's not much. There are Docker files, and then git ignores, some Go files. But the beauty starts when you run the next command. That is, we create an API. Remember what I said earlier? Kubernetes has an API server, and we are extending it. And that's exactly what we are going to do with this command. So you can say, operator SDK create API. We are creating some APIs, and we specify the name of them and the versions, and then, of course, the kind. Did you remember when I was talking about MongoDB, there was MongoDB community kind. Now that kind is there. So for this example, I'm just putting my app as the kind. So I hit enter, and then it asks me whether I want to create the resources. I say yes, create the controller, of course. And then the project structure got updated. And there are some new folders, and there is a folder called controllers. And see, it's controllers, confirming the fact that I said earlier, an operator can be a collection of controllers. So here, you have the my app controller. So this source code is written in Go, and you can see your logic here. It just say, please enter the code. That's it. So you have to do whatever logic you want for your specific application here. And then you can run the operator and get it all working. If it's still not clear, please bear with me. It will be clear in a moment. So now, since I have the code, let me change into that branch. So here, I'm going to go to this branch. And in this branch, I have coded the things that are required. So here, earlier there was a comment saying insert your logic here. So now I have coded the logic. And in the reconcile function, or the reconcile method, is where we write all of our logic related to our operator. It can be refactored into multiple Go files, but still, it's going to be inside this main reconcile function. So what this reconcile function does is, in Kubernetes, we know there's a desired state and the actual state. So through this reconcile function, what it does is, it will try to take the actual state to the desired state. And how, that very important question, how, is what you do with Go code. That how will depend on your business, your application. So in my internship, I did it for the WSO2 identity server, and it may be different from MongoDB. So that is going to be different, and that's why we have to create different operators for different applications. So here, what I have done is, I'm not going to go into the syntax, but I'll say what is done in the code. So you create a deployment, and then we create a service, and then we create an ingress. So those things, service, ingress, and a deployment. And why am I creating those things specifically? So to see it in action, let's fire up a Minikube cluster. So Minikube is what lets you play around with Kubernetes in your local computer. So here, let's see, we are spinning up a Minikube cluster in my computer. And I'll use Lens, which is also a very helpful tool to visualize your clusters. Okay, the Minikube cluster is starting. And by the way, until that loads, I'll go into the next slide because it will be very easy. So here, through our custom operator, what we are going to do is we are creating a custom resource definition called myApp, which we already did using the command, the operator SDK create API. We created the custom resource definition. You can see that custom resource definition if you go into the code. Here, you can see the custom resource definition. Now, this custom resource definition is a native Kubernetes type. Don't get mixed up, okay? The custom resource definition is a native Kubernetes thing, but inside this, we say how our custom resource is going to look like. So here you can say, we need a kind myApp. And there's a whole list of things that you can customize in this custom resource definition. So, okay, the Minikube cluster is running, and now what we can do is, we can run our operator. So to run our operator, or to install it within our Kubernetes cluster, we can run this make install run. Now before that, let's go into our Minikube cluster and see. There's nothing much. So let's run it. Now what we are doing is, we are installing our Kubernetes operator that we just created within our Minikube cluster. It will take around a minute, and then you will have your own Kubernetes operator running in your cluster. Okay. So this is what we have done. We have the custom resource definition, and then we have its application. Okay? So the application part still we didn't do. We are just running the operator first, and then we need to use that operator. So running the operator and using that operator are two different things. So currently what we are doing is running or installing the operator. Okay? It's being installed on our cluster, and now you can see the operator is running within our cluster. So now if you go into our Lens software, you can see now there's a custom resource created called myApp. So this is what we are doing with our operator. And it will create a custom resource. So now we can use this myApp similar to how we use the deployment, config maps, secrets, and all those Kubernetes native kinds. Still, we don't have any workloads. So now we are going to create a workload. How we are going to do that? We are going to create a sample YAML file to use that kind. Now do you see the interesting bit? Earlier, we had to use something like deployment, stateful set, something like that here. But now, we're using myApp. If you have awesome to-do app, you can say to-do app. Like that way, this can be application specific. How Kubernetes know how to interact with this is what we are using Golang. Okay. So now let's kubectl apply this YAML file. Kubectl apply file. Okay, it's a long file name. I thought I had it. Okay, Norris config samples. Okay. Now we're going to apply it, and you can see. Now we have a deployment. Not only that, we should have some ingress created. Yes. And also, we have to have a service created as well. So if you go into services, we should have myApp sample service as well. Still, our pods may be being created. So did you see the user only used a single YAML file, and then kubectl applied it, and then all the needed resources like ingresses, services, deployments are just created in a single go. Now you might say, well, that's basically what Helm charts are for. But the thing is, it's not just about installing or creating the resources, but managing them the way you want to manage them. So all the complex things related to your application, you can put within this Go code. So as an example, in my internship project, I had to deploy the WSO2 identity server. So in that, there were secrets to be handled, config maps, other configurations to be handled. So I coded that within this reconcile logic. So that is different from business to business, application to application. Okay. So currently, I only create the resource within this example, but it can be extended much more than that. Okay, so our pods are running now. Is my ingress ready? So hopefully if I run this, let's go incognito. So for the example, I deployed an Nginx ingress server, so just a sample application. And so it's not loading for some reason. Okay. So I hope I have to go to my Panda now. And trust me, it worked, okay? It worked yesterday, it worked the morning, and yeah, it worked. So if you go into that URL, what happens is, you should be able to see the ingress, and it works, okay? Trust me. Take my word, things don't work the last moment you want them to work, but it worked, okay? So the key takeaway is an operator works by allowing you to encode or embed your application-specific logic as Go or using Ansible or whatever programming language, and you can just give the user the ability to do everything, deployment, controlling, managing, updates, everything using a single YAML. So for example, from my project, deploying WSO2 identity server within a Kubernetes cluster can be a complex thing. But through the operator, a user can do it using a single YAML file. So, there will be a kind called WSO2IS, and then kubectl apply. No matter how complicated the deployment process is, the user doesn't have to worry about it. Everything, every complex configuration and the processes are taken care by the operator. Okay, so that's for the demo 1, and for the demo 2, I have created a GKE, or the Google Kubernetes engine, and I was hoping to deploy the MongoDB operator, but since time does not permit, I'll just say how to do it. Of course, I have a cluster on there as well. The thing is, we have to use a Helm chart. So here, we are installing the operator using a Helm chart. We can use various methods to install operators. You can do kubectl apply. We can use Helm chart, Helm install. Or if you are developing the operator yourself, you can just do make install run, just like I did. So it's not just one thing to do a specific thing. There are multiple ways, okay? And then you can create the the secrets for the MongoDB database, and then you can use the kind like this. So here the kind will be MongoDB community. Okay? So since it's basically the same thing, I won't go into the details much. So if you want, you can try out this operator. It's open source as well. And several concerns regarding operators. The thing is, usually, it's good to have your operator in a separate namespace than your application. Now, this doesn't have to be the case always, so it can depend on your business requirements, but it's generally better to have your operators in a separate namespace. Now, when you're writing a Go operator, you have to follow basic programming best practices. Like you have to refactor the code, you have to add comments as well, because this operator code is not very structured. You have to create the structure yourself. Also, you have to run unit tests wherever necessary, because from my experience, if you do not write unit tests from early on, you're going to have a very hard time writing tests later on, because this code, operator code, have to interact with a Kubernetes cluster, and then you have to talk about the reconcile logic and your business use cases. There may be various clustering within your application itself. So everything has to be tested from the moment you are writing the code. Otherwise, you will have a headache when you're going to write the tests later on. And then when writing the tests, you can use packages like Ginkgo and Gomega. So the operator SDK has their inbuilt testing tool or the package, but they themselves do not recommend to use it. The interesting thing about Ginkgo is that you can write unit tests just like you are reading an English sentence. Like it has to be like that way. You can write unit tests easily. So I'm just telling from my experience, it's better to use these packages if you're going to write an operator. Okay, summary before we are concluding. Kubernetes is very complex. We know it has an API server and all other good components. But when it comes to enterprise applications, they may have their own set of complex requirements that are better offloaded into some automation tool like a Kubernetes operator. Otherwise, you have to invest in a person who has that domain knowledge to take care of it. If you have a software to do it, you can, of course, replicate it, you can reuse it, you can distribute it as well. In fact, my project for the WSO2 identity server is an open public repo, so you can go refer it as well. And then the reconcile logic is dependent on your application, so you can decide how your application is going to interact with the clusters. And then after you are done creating your operator, you can distribute it as a Docker image on Docker Hub. So other users around the world can use your operator as well. It's just Docker build and then push it as a simple Docker image. It's nothing fancy it being an operator. It's just a Docker image. And then you can deploy it on a cluster as a deployment. And then you can automatically create YAML files which are using that custom kind. So that's it. I hope I gave some introduction to what Kubernetes operators are. They're very complex. Of course, I started learning Kubernetes this January, this year. So understanding these concepts was very difficult for me. That's why I wanted to give my experience I had very little knowledge on Kubernetes itself, let alone operators. So I hope I gave some beginner's perspective to intermediate knowledge on Kubernetes operators. And if you took those 3 key takeaways from my talk, what's an operator, what problem does it solve, how can you get started? I hope if you get these 3, it's a pleasure of me. Thank you very much. I'm Rukshan Senanayaka. You can reach out to any questions you have via my social media. And I'm thankful for the opportunity. And thank you very much. Have a nice day.